Hi there, welcome to our presentation. We're group 3 from the 5 p.m. advanced tutorial on Tuesday. My name is Samuel Jansen and I'll be giving the introduction. Our project is titled The Topology-Based Combating of False Information. So since the early 1960s, there's been a lot of study into the way information is shared by humans. But in the age of social media, it's a very different platform. For example, you can't be sure if what you're reading on the internet is always true, particularly caused by the phenomena that false information is spread much more quickly than true information on the internet. So the goals of our project are to use the topology of social networks to understand how information spread, particularly the difference between true and false information. And then we examine different parameters of complex networks based on their topology to understand how this information is spread. So our clients and stakeholders, our clients are faculty of the University of Sydney. We've got Bassem Suleiman, Wahid Muhammad, and Abdullah Lakhdari. And other stakeholders could be people understanding diffusion networks, people interested in the philosophical question of why does false information spread faster than true information, and particularly fact-checking institutions who may be looking for topological factors related to information diffusion, not only to enhance their own goals, but also to find the best intervention points to stop the spread of false information. So our project involves two main elements. The first one is about randomly generating networks and performing diffusion for true and false information based on many different parameters provided by the user. So they can provide the parameters necessary for the generation and also use different models of true and false information spread to see how it impacts the results. The second element is extracting tweets directly from Twitter using the Twitter API by hashtag and also one stored locally in our database, and then showing the diffusion networks for those tweets. For some more related material, you can look at Hoaxy, which is a tool that visualizes the spread of articles online. Unlike our project, it doesn't actually analyze the topology or the causes of the spread, it just presents the information. And then there's a paper by Cheng, Adamic, Dow, Kleinberg, and Leskovec, which are staff from Facebook and faculty from Stanford, titled Can Cascades Be Predicted? And it models the features of data diffusion and concludes views is very significant. And so we use this to build a topological model based on connectedness through things like degree, page rank, betweenness, and closeness as predictors of views. And we also include randomly sampled nodes as a control.
These are the user stories which relate to the experiment side of the site. We're going to go through each user story individually alongside the implementation for that story. The first story is researchers want to be given a startup screen where they're presented with information and understand the functionality of the site. As you can see, we've got a nice startup page here that walks them through that. The second story is researchers want to generate diffusion networks and be able to visualize the networks. So here we see a diffusion network being generated, and it appears on the page, and you can see the generated diffusion network. The third story is users want to be able to modify individual parameters, so we can see individual parameters being modified and rejected if they're invalid. And yeah. The third story is researchers want to be able to use various centrality metrics to run simulations. So here we see users selecting various centrality metrics, and a node, as highlighted in the different color here, is selected as the node sample. We also want to run simulations on the sampled nodes. So here we can press simulation and we can visualize the simulation spreading. Simultaneously, we want to see the steps taken for the simulation, and with that slide that we just showed, we can run the simulation. We can see how the spread occurs. And finally, users want to be able to interact with the visualization so that they can better present and understand their findings. And as you can see here, we're dragging around the nodes and hovering over them, moving them around.
Next, I'm going to talk about the key requirements for Twitter pods, which have been written as user stories. They are clear and sensible, described, and relevant to the user's needs. We have totally 10 user stories for Twitter pods. First half of them are generated before the first demo, including the features of backend extraction, hashtag, graph display, and the centrality calculation. The rest of them are generated after the first demo, including the subgraph of the network, the login and register function, more filters for the data extraction, and the setup of database to store the Twitter API data. For user story are well implemented. The quality of work is good enough since we have implemented all the requirements. Next, I'm going to demonstrate the implementation of work required by the clients associated with the user story. Here is our backend. The information is extracted and stored which satisfy the first user story. The second user story is also implemented since the graph of retweet is displayed. Each edge in the graph represents an event of retweets. For this user story, the hashtag can be specified in the left menu, and then the displayed nodes in the graph are all about the retweet of this hashtag. The fourth user story requires us to show the centrality of each node. We make a table containing the original tweet ID, the centrality of it, and the retweet ID. Thus, the user can check the table on the right side to find the centrality of each node straightly. The next feature is the subgraph of follower network. You can click each node on graph to find the follower graph. Here we click this node, and here is our follower graph. We also implement the feature of register so that the user can get the account of the website. If the user gets an account, then they can log in the website, which satisfies the user story number 7. We also add 2 filters after the first demo. The first is the time frame. If the user specifies the time frame, all the nodes extracted and displayed will represent the tweets after that year. The second filter is the number so that the user can define the number that they want in the graph. The final user story we implement is the data storing. Now we have a button called show history sample on the left menu, so that the user can straightly extract the data from database. If the data has been already searched before, the user does not need to use the run button and wait for the Twitter API giving the data because the speed of Twitter API passing data is very slow.
So Liang and I will quickly talk about the different types of testing that we did. So for the experiment side, we had an automated pipeline on commit, which ran our different unit tests, and we also had different acceptance criteria for the user stories. So we ran step 2 of the pipeline, which just set up our environment and ran yarn tests. An example was what was run by yarn test. Say the unit tests for our network diffusion operations, which considers lots of different edge cases for the algorithms, mostly based on BFS style sort of things. So the main things like disconnected nodes, no edges, simple trees, making sure everything runs correctly. For the acceptance testing, I guess a lot was demonstrated earlier by Alex, but we also had abnormal or boundary criteria for different. I'll just go over these ones quickly. So if no page shows for the start page, then that would be. If you aren't able to generate a network as well, if you are unable to generate a network matching your parameters specified, or you don't see a network at all, then that is, and also if you're unable to sample the nodes and or the sample doesn't match your parameters. If no diffusion shows or the diffusion doesn't match the parameters specified, that's not correct. And if the slider does not impact the visualization for the timing of the diffusion, and if you aren't able to interact with the visualization. So for all these testing, as we continued our implementation, we made sure everything was still working fine and the user would be able to.
Hi, let me introduce the testing for the Twitter part backend code. So we do the unit testing and system testing for the Twitter part backend. And we construct a set of test cases to test the quality of Twitter backend code. So here, as you can see, there are three main test files which test different parts in the Twitter backend. So for the filter follower and filter retweet, these are two basic modules that we use to fetch the data from the Twitter API. And we do the unit testing for these two parts. And for the model, and this is the API that we provide for our front end. And we do the API testing and the system testing for this part. And to show our code quality, here I display the testing coverage for our backend code. So as you can see, we achieve a total coverage of 81%, which is pretty good. And we test different scenarios in different test cases, and these can make sure our code quality is very good. And we also use the continuous integration for our commits. And we use Bitbucket pipeline to do our CI process. Here we do our testing process for the step 1, which tests the Twitter backend code. And for each commit to the master, it will automatically build the test cases and run them to make sure there's no error in the test cases. Otherwise, we have to figure them out and fix them. We also create a different acceptance test for the user stories in the Twitter part. So here are the user stories for the Twitter part, and we construct a set of different acceptance criteria for the user story. And we do the acceptance test for these user stories and make sure we achieve the requirements that the client wants.
Next, I'm going to talk about the discipline knowledge application from my major. As a computer science major student, I use the data structure and algorithm which help the network representation and different algorithms for manipulating them. Knowledge including using the JSON to cache the data from Twitter API. I use the snap Stanford module to build the graph for information diffusion based on the JSON file. Calculate the betweenness, closeness, page rank, centrality of each node. Using the BFS to track the information diffusion started from a certain node. Using the SQL to store the data.
Here, I want to show how I use the knowledge of software development in our project. So first of all, is continuous integration. So first of all, we use Bitbucket pipeline to set our CI process. Besides, we also use different CI process for different branches. And finally, we have different steps in one CI process. For example, in step 1, we do the testing for the Twitter backend. And for step 2, we do the testing for the front end. And the CI process can make sure our project can be run at any time. And next is extreme programming. The extreme programming is a very useful tool to help us build better projects. So I made a very clear role arrangement for each group member, and so they can check what's their role in different weeks. And I also remind our group members to follow in their responsibility. And I also learned the extreme programming at the start of the project. And I also made a summary of extreme programming. And this can help us to do better in extreme programming. And finally, is the MVC framework for the backend code. So I divide our backend code into three main parts: view, controller, and model. So the view is the page and the user can interact and catch the user's request, and this will be passed to the controller. And the controller catch this request and run the corresponding handling function. And it may cause the model to create a corresponding view. And model will do some logical part and finally return a view to the user. And that's the MVC framework that we use in our project.
So through my mathematics major, I have a general understanding of the different components involved in topology and how they work together, and I'm able to read more advanced mathematical literature to help for research purposes.
For data science discipline knowledge, the project runs experiments 50 times and calculates the average values to figure out which attribute from PageRank, centrality, betweenness, and closeness has the highest correlation with the calculation of the largest spread, as well as extraction of the useful data in dataset, such as Snap and Twitter stream. Then use SQL queries to store these useful dataset in the database.
Our project was quite advanced in nature, requiring that we had a deep understanding of many complex network analysis algorithms and develop a highly interactive experience making use of cutting-edge web technologies in the form of a single-page application. We utilized a TypeScript-based React application alongside the D3 library to create a fully customized graph visualization to demonstrate diffusions within the network. A deep and advanced understanding of front-end development was required to build an application with this level of interactivity and to be productive within this modern codebase.
So Anthony and I will just quickly discuss our professional relationship with the client and how we were able to maintain the progress they had expected and attain the correct results given by the scope. And so in terms of responding to changes, we kept a product backlog of all the tasks we plan to implement, and we were given deadlines and different set priorities by the clients on what they would expect in each week. During the meetings, we would open discussions on the specifications. For example, we came with several suggestions for the way we could model the diffusion patterns and clarified that in the product backlog. And I'd say we effectively met their expectations. And we also suggested some new ideas to enhance the features. For example, we suggested a start page to give an introduction to the page and the general idea of what the tool's used for, how to use it, and what you would expect to see from using the program.
There was some feedback from the client since first demo. First, there needs more testing for the project, which we already did, as Sam and Liang mentioned earlier. The second is to change the UI for the Twitter part. Now we have already abandoned the old version for Twitter and implement it in React, and the visualization of the nodes become better than the old one. Lastly, they required us to add more usability to the website. So we added an intro page so the user can have more idea what the website is about and how to use it. We also allow users to log in so the website will remember what they have searched in the past. For other features, we made the table feature collapsible instead of transparent, which has low usability. We made the distribution of the follower network become steady instead of moving randomly. We made the user be able to click the nodes in the network instead of clicking in buttons in the tables to make user more clear which follower network is displaying. We also allowed user to specify time of the tweet and number of nodes they want to see in the network. A group process and collaboration. Each week, every team member follows the corresponding roles specified on Wiki. Manager does the status report, tracker does the meeting minutes, and customer communicates with the clients. The whole project was divided into two parts, experiment and Twitter, where two teams working together and later combine and integrate two parts. The two parts are interrelated closely as the demonstration of the experiment part will be used to display the Twitter follower diffusion network. Every week, there will be different things from the product backlog that needs to be done for both parts. Equal amount of work will be allocated to each member, and due dates are set according to the relationship of the tasks. Each team member was able to finish the allocated task on time. Each allocated task becomes an issue in Jira and assigned to the corresponding person. We track the status of the issue by seeing if it's in the done column or in progress. If it's in the backlog, it means it is not yet started. Bitbucket is used for version control, where all the codes are saved and the version history can be viewed. Wiki is used as the demonstration of all the documents included within the project, including the project scope, user story, role arrangement, meeting minutes, and status report. Slack is the communication channel that the team uses. Bitbucket and Jira are connected to Slack, so if someone pushes a commit or creates an issue on Jira, there will be notification in Slack to everyone. By using these tools, the team are able to work effectively. Every Friday, 12 to 1 p.m. is the scheduled meeting with the clients, where we use a presentation to show what have been done for the past week. Hear the comments from them and decide what will be done before the next meeting. Before the meeting, there will be an email sent to the client, debriefing the major updates on the project. By this continuous interaction with the client, the group was able to move forward and improve different aspects of the project. For instance, for the first demo, the client said there should be more testing for the project, and we did the testing a few weeks later.
Let me make a summary of our group members' contribution to the demo. Anthony demonstrates how we deal with the client feedback, and he also shows the whole group process. Sam does the overview part, and he also shows the testing for the experiment part, and he also shows the product backlog of our project. For Alex, he does the system specification, and he also shows how we implement the system. And for me, I show the testing for the Twitter part, and I also made this summary for the demo. And for Hao-Lin, he finishes the system specification and the system implementation together with Alex. Each group member also shows how they use the knowledge from their major. And thank you for watching this video.